Now I want to show how you can use the Cardano CLI to actually deploy a Plutus smart contract to the Cardano mainnet or testnet and to interact with it. So the first thing you need to do is you must run a Cardano node. And if you go to the input-output GitHub repository Cardano node, then here you see that at the moment Cardano node version 1.33.0 is the latest one. So if we click on here, the release nodes, in particular here we have downloads. If we go there, so I mean it's up to you, but I use the Hydra binaries, and then because I use Linux, I downloaded this one and got the executable from there and then installed it on my system. So I now have the Cardano node available, so I can do Cardano node minus version, and it looks like the right version. In addition to the executable for the node itself, you also need configuration files, so there's a link here as well. So I will do this for the testnet, but for the mainnet it would be exactly the same, except that you need other configurations files. So I needed the first ones, so I didn't need db-sync-config and rest-config, but config, Byron Genesis, Shelly Genesis, Alonso Genesis, and topology. So I created a folder in this week's code folder that I called testnet, and I downloaded these configuration files and put them into that folder. And in addition to that, I created the simple bash script that actually starts the node. So if we look at that, so Cardano node accepts a run command, and then you have to specify the position of various config files. So you have to say where the topology JSON file is and the config JSON file. Then you can freely choose a path to the database folder. So the node will set up a database for the blockchain. So I just use DB here. Then you can also freely choose a name for the node socket that is then used by other tools to actually interact with the node. And then you need host address, so that's just localhost, and port, which I chose as 3001. If I change into this testnet folder and I start the node by executing my shell script, then it should look something like that for you. So if you start fresh, just install the node, download the configuration files, and then start the node, you will have to wait for a couple of hours until the testnet has synchronized. Part of this Hydra binary download is not only the Cardano node, but also the Cardano CLI. And that actually comes with an excellent built-in help, which you can always access with --help. So we see available commands. So these are the top level commands, but all of those then have sub-commands as well. And you always can get help for more specific commands by, for example, typing Cardano CLI address --help or key --help. In order to try our Plutus contracts, we need to create some keys first. So we need at least two parties, two wallets basically, if we want to try out the parameterized contract as an example. So let's start with that. And you can do that with subcommands of the Cardano CLI address command. So if I do Cardano CLI address --help, then we see there's a subcommand that's called keygen. Create an address key pair, and that's what we want. So if I add this keygen, then I see various options. So by default, it will be a normal Shelly era key, and we can specify a verification key file and a signing key file to put the generated keys to. So let's do this twice. So I have verification key file, let's say 01 v key, and signing key file 01 s key. Okay, now those files should be there. They are. Let's do it again to generate a second key pair. And there they are. If we like, we can look at one of those files. It's actually quite nice. It's not just the key, it has some information, so we actually see that this is a payment verification key Shelly and the actual key serialized using CBOR. We also would like addresses for those generated key pairs, payment addresses. And that's another feature offered by the address command. And it's this build subcommand. So if we look at that, we see we can specify a payment verification key file that we just created in the previous step. We don't want to bother with staking, so we could add a staking component to the address if we want to actually delegate to a staking pool. But for simplicity, we don't do this now. And we must specify whether we are on the mainnet or on the testnet. And if we are on the testnet, which we are, we need to specify the so-called magic. So where do we find that? For example, it's contained in this Shelly Genesis file that we downloaded. So if we look at that, at the testnet Shelly Genesis JSON, and search for magic, then we see it here, network magic. So that's the one we need. So let's try this. So Cardano CLI address build. Now payment verification key file. Let's start with the first key pair. So that was 01.v key. Now testnet magic, the number we just looked up. And finally, we can specify an out file where to put the address. So let's do 01.address. We can look at that. There we have the address, the payment address corresponding to the first key pair without a staking component. Let's do it for the second key pair as well. There's our second address. Now we need some test ADA to play with. And the easiest way to get some is using the faucet. So let's copy this first address. And you easily find the faucet by simply Googling for Cardano testnet faucet. So it's at this address, testnets.cardano.org, en testnets Cardano tools faucet. And you simply have to paste the address here and say that you're not a robot and then request funds. And now the first address should be funded. In order to see whether it worked, we can query the blockchain. So one of the other commands that the Cardano CLI offers is called query. And there are various options. We want the UTXO, where we can look up all UTXOs sitting at a specified address. However, for that to work, the Cardano CLI has to interact with the running node. So you must have the node running in another process, in another terminal. And you have to set this environment variable to the node socket. So I can do this with export Cardano node socket path node socket. And now let's see this Cardano CLI query UTXO. So what I have to do is I have to specify the address I'm querying. So let's do this. That was saved in the 001 address. And I have to again specify the testnet magic. We looked that up before. Let's just find it again. It was here. See whether that works. It does, and we see the test ADA have arrived. So there's only one UTXO at this address. So this was the transaction hash, the output index. So combination of those two specifies the UTXO, and we see the amount is 1000 ADA, 1 billion Loveless. So the faucet worked. Now in order to fund the second address, we can't immediately reuse the faucet because the faucet, if you don't happen to have an API key, only works once every 24 hours. So we must find another way if we don't want to wait for a day to get some ADA to the second address. What we can do is use the Cardano CLI to build a transaction that sends some ADA, let's say 10 ADA, from our first address to our second address. And I have prepared that already because it's quite complicated, so I didn't want to type it live. So I actually need 3 invocations of the Cardano CLI. First, I build the transaction body. That's actually the most complicated step. Then I need to sign that to create a signed transaction. And finally, I have to submit it. So this Cardano CLI transaction build command is actually quite high level. There's also a build raw command where you can or have to specify everything about your transaction by hand. But this build command does some things automatically. For example, it automatically calculates the fees and takes care of them, and it also automatically creates change outputs. So if your inputs are higher than your outputs, then it will automatically create change outputs that go back to your address, an address that you specify. And you can do whatever you like, all sorts of complicated transactions with this, also involving Plutus, as we will see in a bit. But for now, just simple transfer of ADA. So we have to specify the era in this case, because the default is the Mary era. So that's Alonso. Then again, the testnet magic. Then we have to give the change address. So that should be our first address. Then at least one input. So where we take what we sent from. And this I looked up here. So we had queried the UTXOs at that address, and we had seen the 1000 ADA coming from the faucet. And we see here the transaction ID and the index. So the syntax to specify this UTXO as input is to first the ID, then a hash, and then the index. Then an output. So we say we want to send something to address 2, and then we must specify the amount. So this would be 10 ADA. And finally, a file name where to write this generated transaction body to. So if all goes well, that will create this transaction body, write it to this file. Then the next step is to sign it. So we must specify the body file, which is this one. Then the position of the signing key file, that one we created earlier. Again, the testnet magic, and then a file name for the file with the signed transaction, which I chose as tx.signed in this case. And finally, we can submit it to the testnet using transaction submit, where we only have to specify the testnet magic and the file containing the signed transaction, which is this one here. So if all goes well, then this should work, and it should send 10 ADA from the first address to the second address. Well, that already looks promising. So now there's a block on Cardano, both the testnet and the mainnet, on average every 20 seconds. But sometimes it can be much faster, but sometimes it also takes much more time. So let's see. So at the moment, nothing has happened yet. So the full 1000 ADA are still there. So let's wait a bit more. So after waiting a while, the transaction seems to have happened. So this original UTXO that was created by the faucet to send us the 1000 ADA disappeared. And now we have a new UTXO which contains less than 1000 ADA. So actually it's 989.8 ADA. So the 10 are missing that we sent to address 2, and the transaction fees are missing. And this is now the chain's output that the transaction build command automatically generated for us. We can also now check the other address and see whether the 10 ADA arrived. And indeed they did. So we have now 10 ADA at the second address. So now both our addresses are funded, and we can start with the actual example with Plutus. Now, in order to get started with Plutus, using Plutus in the Cardano CLI, we have to do some work first. We have to serialize and write to disk various Plutus types. So I created the module deploy where I'm doing this. So one of the issues is that in order to do this, we use the Cardano API, which is the Haskell library that the Cardano CLI uses under the hood. So the Cardano API contains all the functionality that we need to talk to the node, submit transactions, query the blockchain, and so on. And the Cardano API has its own data type. It's very similar to the Plutus data type. It looks exactly the same, but it's a different type. So first we convert from Plutus data to so-called script data from the Cardano API. That's this helper function. And then I provided a helper function here, write JSON, that gets something that's an instance of two data and a file, and then serializes this value to that file in JSON. So it first has to convert it to data, then to the API version of data, the script data, and then there in the Cardano API there is something called script data to JSON. And there are actually two ways to serialize to the JSON, so-called detailed schema and no schema. For the detailed schema is used if you want JSON in a file, and the no schema is used if you want to inline it in the command directly. I'm using the detailed schema, so I want it in a file. Then encode comes from the data.asia library to encode something as JSON, and then finally we write it to the specified file. And I have a specialized version here, write unit, that writes the unit value to this file unit.json. Because recall, both our datum and our redeemer are always just unit. So all we need is the serialized version of unit. So from the REPL I can do this, call write unit, and then I can check, and there we have it. So this is how unit is encoded in JSON. Okay, the second thing we need is we need the actual script, so our Plutus validator. So another helper function chooses various functionality from the API. So to convert a Plutus validator into a script and then write it to a file. And we want to apply it to our parameterized contract. And this is specialized here, but remember we need the parameter. So in particular we need the beneficiary and we need the deadline. And the beneficiary is the payment pub key hash. So we need the payment pub key hash of our second address. We can get that using the Cardano CLI again. So if we check the address command, we see there's one called key hash, one subcommand called key hash. And this does what we want. So we must provide the payment verification key file, which was 02 vkey, and an out file. Let's call it 02PKH. And this is the string that I used here. Okay, and we need a deadline. So I use the online epoch converter, so-called epoch converter. So I just googled POSIX time conversion online or something and found this. So you can specify the date and the time in human readable form, and then you get the POSIX time, this timestamp in milliseconds. So this is the one I used here. So it's a bit in the future for me while I'm recording this now. One final thing we need in preparation is we need the actual address corresponding to the script. So if we see here still the help for the address command, there is the subcommand build script. And we can use that to build the script address. So we need the script file, which we have once we execute this. So let's do that, right? Vesting validator. Okay. So the script file is vesting Plutus. And we need the testnet magic again. And an out file. Let's call that vesting.adrel. Okay. And seeing as we have that now, so now we can actually write the GIF functionality. So I prepared that again. So first of all, we are again in the Alonso era. Testnet magic, change address. That's the same. The txin I got with Cardano CLI query, so I checked the UTXO and checked where my funds are. So I specified that there. So now I want to make a gift, and a gift, let's say over 200 ADA, and lock those in this script in this contract at the script address. So I generate an output for my transaction. Now at this vesting address that we just computed, 200 ADA. Now I need to specify the datum hash, and there are various options in the Cardano CLI, so you can enter the hash directly, or you can specify a JSON file, which I want to do. So recall we serialize the unit value from Haskell to this unit.json file. So by specifying this txout datum hash file parameter with unit.json, I'm doing exactly that. So I'm specifying that as my datum. And finally out file. And the signing and the submission is as before. And I actually already executed that, so we can check that now at the script address. So here I now specified the script address, so we can check that the 200 ADA are sitting there. Now the second wallet wants to grab it. So I prepared a file for that as well. So beginning same, Alonso era, testnet magic. Change address is now the address of the second address. Now we want to spend this script output. So the txin here is now this. So here transaction ID and index 1, which is specified here. And now we have to do all sorts of things to actually consume such a script output. So we need the actual script. As I explained before, the producing transaction, the GIF transaction, only needs the script hash or the address, the script address. But if you want to spend something sitting at the script address, you have to provide the actual script. And so we do this with txin script file. And recall we wrote the script to vesting.plutus. Now we must provide the actual datum, not just the hash. So, but that is this unit value, which we have in file unit.json, and using txin datum file, we can specify a JSON file containing the datum. Now we must specify the redeemer, which in our case is also unit. So txin redeemer file, same file, unit.json. Now collateral. We haven't talked about that yet. So normally, as I explained, it will never happen that you have to pay for failed validation, because the moment you want to submit a transaction that wants to spend a script output and validation fails, the node will simply refuse to accept that transaction. But if you really, really insist, you can somehow circumvent that. And then it could happen that a script actually fails, so the node, other nodes have to validate your transaction and would fail. So then some costs are incurred. And the nodes need to be reimbursed for that. Otherwise, the system would be open to denial of service attacks. So in order to handle that, there's this concept of collateral. So whenever you try to do something involving Plutus, where Plutus scripts have to be executed. So normally that's the case when you spend a script output. There are other cases, for example, if you mint a native token using Plutus. So in those cases, you must always specify a UTXO that belongs to yourself and that contains only ADA, no other native tokens. And that's the so-called collateral. And that collateral must be large enough to basically cover the costs if validation failed. So as I said, normally if you do the normal thing using the Cardano CLI or the Plutus PAB to submit transactions, that should never be a concern. Nothing can go wrong. You will never forfeit the collateral. But nevertheless, you need to specify it. So I just checked here at this 02 address, and there's only this one UTXO, so this is the one that I specified as collateral here. Then we must specify that this second address actually needs to sign, because the script will check, if you recall the logic, the actual business logic of this vesting contract or the parameterized contract, it will check that the beneficiary has signed. So we must explicitly mention that here, that this is a required signature. So this is again this public key hash that we computed earlier of the address 2. Then we need protocol parameters. So I have them here in protocol.json. How do we get them? That is another query. So we saw the UTXO query, but there is also another one called protocol parameters. And that gives you the protocol parameters and writes them in a file. So I did that already and got them here in this file protocol.json. So let's look at the grep again. And finally, we must say where it goes. So now we can try this, but the deadline has not been reached yet. So I set the deadline a bit in the future, and it's still 10 minutes while I'm recording that until the deadline has been reached. So this should not work. And indeed, we get an error during the build step, so we can ignore this one. Obviously, submission will fail if the build doesn't work, because then there's nothing to submit. So this is just a follow-up error. So the actual error happens during the build step. And there it says the following scripts have execution failures. This script was transaction input 0, failed with. So if there are several scripts, it would specify which of the scripts failed. And then we see the Plutus script evaluation failed, an error has occurred, user error, the provided Plutus code called error, script debugging logs, deadline not reached. And this is actually very nice, because if you recall, that's this trace if false that we provided in the parameterized contract and also in the other contracts. So here this actually appears. So we do get some feedback why our script failed, why validation failed, if we use these trace commands. So we see, as expected, that we can't grep because the deadline has not been reached. So now I must wait until the deadline has been reached and then try again. By now the deadline has been reached, and I did try again, and I still get the same error. And the reason is that I forgot something important, namely to specify the validity interval of the transaction in the grep. So as I explained earlier, by default, the transaction is valid starting at Genesis forever. But then Plutus validation will fail because the validator can't ensure that the deadline has actually been reached, because it doesn't know what the current time is. So we have to specify that. And actually in the Cardano CLI transaction build, we see there is a parameter here, invalid before slot, invalid hereafter slot. So we can use that. So we need to use the invalid before slot. And hopefully that slot should be after the deadline, and then we should be good. So slot. As I also explained before, Plutus uses real time, but Cardano itself, the Cardano node, uses slots. So we must know what the current slot is. And that we can do with yet another query command. So Cardano CLI query tip. That just needs the testnet magic again. So let's try this. Okay, so right now, while I'm recording this, this is the current slot. So let's add this here in the grep. So invalid before, and that slot I looked up. Let's try once more. And now it was successfully submitted. So let's query address 2 again. And we see the gift has arrived. So it's a little bit less than 200 ADA because we paid the transaction fee for the grab from that. If you recall, the only TX in we specified was the UTXO at the script address. So the transaction fee comes out of that pot. But it worked. So we were finally able to retrieve the gift. This completes this walkthrough on how to actually right now work with Plutus on the Cardano testnet. And mainnet would be exactly the same, except everywhere where I use testnet magic, you would just use mainnet instead. So in principle, everything that's possible with Plutus can be done with the Cardano CLI. But as you also saw, it's a very elaborate process and there are lots of manual steps. So obviously, once the Plutus PAB is ready, this will become much simpler.